Okay, lesson 3.2, polynomial inequalities in one variable. So given a polynomial, then p of x is greater than 0, p of x is less than 0, are polynomial inequalities. Okay, so let's remember what a polynomial is. Okay, it's the sum or difference of terms. We know that the exponents have to be positive integers. Okay, so we can't have things like the square root of x. We can't have things like 1 over x squared. Okay, two methods to solve polynomial inequalities. First, sign values between zeros on a number line, or we could graph the polynomial using all the information we know about the characteristics of a graph. P of x is greater than 0. That's where the graph of the function is above the x-axis. Or p of x is less than 0 would represent all the parts on the graph where the function is below the x-axis. So let me just remind you that p of x is y. Okay, that's our function notation. So if I have a function that's positive, and that means all my y values are positive. So where would my y values be positive? Above the x-axis. Okay, because up here is where all our y values are positive. So if we're saying our function is less than 0, that's saying where are your y values negative? So that, of course, my y values are negative when I'm below the x-axis. So we're going to look at both methods. And here's our y. Okay. So find all solutions for each polynomial inequality. So I have x plus 3 times x minus 3 is greater than or equal to 0. When we were studying graphing polynomials, when a function was already in factored form, it made the work easier for us. So from factored form, I know that the zeros of the function are plus or minus 3. The degree of this polynomial is 2, and my lead coefficient is positive. So let's recall, right? The degree is the sum of each factor's exponent. So that gives me my degree of 2. Okay, so positive 3, negative 3. This is just an upward facing parabola. Okay, and we don't even care to find the vertex. We're just looking for the basic shape of it, because now all we need is where the function is in a given region. So where does that come from? Now I look at my inequality. So I'm looking for all the intervals where the function is graphed above the x-axis. So where my function is greater than or equal to 0, that's all the parts. Oh, that's not what I want. That's all the parts where my graph is above the x-axis. So I'm going to highlight those parts. I can equal 0, so I am allowed to include the x-intercept. So to write my answer, then this is for all values of x less than or equal to negative 3, or all values of x bigger than or equal to positive 3. And that would be my solution. Okay, we'll talk about the number line. We'll do an example with that also. But if you're able to use the graph, it's that much easier for you. Okay, so another function, factored form. Let me identify my zeros first. Positive 4, negative 1/2, positive 2. This factor has an even exponent, an even degree, so that's going to be a bounce point on the graph of the polynomial. So I'm going to mark that. The degree of the polynomial, 2 plus 1 gives me a degree of 4. My lead coefficient is positive, so my end behavior is going to be up, up. It'll resemble the end behavior of an upward facing parabola. All right, so I'm going to graph my x-intercepts, 2, 3, 4, 2, and negative half. So now I start up, I cross, I bounce, and then I cross at 4. So my end behavior is correct, okay? 2 is the bounce point, so I stay in the negative region. And now I go back to my inequality. I'm looking for where all my y values are less than 0. Notice it cannot equal 0. So I'm looking for the region that's below the x-axis. But since it can't equal 0, I have to exclude my zeros when I'm writing my inequality. So my answer would be all values from negative 1/2 to 2. Okay, remember this is our inequality that shows between. And then again from 2 to 4. So I have to break the inequalities up at 2 because the function's not allowed to equal 2. And if I plug 2 back into my original, I would get an answer of 0. So the reason I break this up, I have to exclude 2 from my answer. Okay. Sorry, pen gets a little crazy. All right, next one, find all solutions for the polynomial. So now my function's not in factored form, but graphing, trust me, is a lot easier to look at. So I'm going to attempt to factor this. Factors of 2x squared are 2x and x. I need my factors of negative 5, and then when I check it, it has to add to positive 3. So I'm going to put negative 5, positive 1. So on my check step, I get negative 5x, and I get positive 2x. When I add those together, I get a sum of negative 3x. Not what I need. I need it to add to positive 3x. So all I have to do there, change the signs. So the 5 has to be positive, the 1 has to be negative. Now when I check my answer, I do get the correct middle term. If factoring is still difficult for you, you just have to practice. If you're guessing and checking, if you're putting numbers into the polynomial, you have to check that they work to get the original function. Okay, so I'm going to erase these. So now that my polynomial is in factored form, negative 5/2, positive 1 are my zeros. My degree is 2. Okay, right? The original function's in standard form. Lead coefficient is positive. So I have all of the information I need. So I have a 0 of 1 and negative 1/2, upward facing parabola. Okay, now I go back. What am I looking for? I'm looking for where my function is less than 0. So I'm looking at the part of my graph that's below the x-axis. So I need my negative y values. I cannot equal 0, so I can't include my x-intercepts on there. So what's my answer? From all my values between negative 5/2 and positive 2. Okay, now for our last example, we're going to use the number line because we haven't graphed polynomials in this form, rational polynomials, right? A numerator and a denominator. So let's just talk about this for a minute. When we look at a fraction, we know that a possible domain restriction exists because we can never divide by the number 0. So in addition to finding what the zeros are, we need to find the restrictions. So the zeros of the function will come from where the numerator is equal to 0. Because think about what that represents in the fraction. 0 divided by any number will always give me 0. So when I'm finding my zeros, I just need to set the numerator equal to 0. My restrictions come from where the denominator equals 0. because I'm never allowed to divide by 0. It would give us an answer that does not exist. So your restrictions come from setting the denominator equal to 0 and solving for x. So these pieces of information are the values that go on the number line. Okay, so let's first find our zeros. I'm going to set my numerator equal to 0. Okay, GCF of x squared. So I factor that out. I'm left with x squared minus 4. Then I can factor this further, difference of perfect squares. Okay, so my 3 zeros are 0 plus or minus 2. Now my restrictions, that's my domain restrictions. So the domain, I set the denominator equal to 0, and I get a restricted value of -1. Disregard that slide. So on the number line, I'm going to put my zeros and my restrictions in order on the number line. So the smallest value is -2, then -1, then I have 0, and then I have +2. Okay, and we're going to stop there. We'll actually complete the number line in class. No additional homework unless it was assigned in class as well.